Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Clone Alone by PageDo, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Clones. The 5 shaded region highlighted by cell cages in grid box 8 and 9 is cloned 3 times throughout the 9 by 9 grid. This is box 8 and this is box 9 because we usually use, when we designate boxes, we usually designate them in typical Western reading notation, which is from left to right and top to bottom. So the top leftmost cell or box is box 1. The top central box is box 2, box 3, box 4, 5, 6, 7, 8, and 9. So when they're talking about boxes 8 and 9, they're talking about these boxes here. So the 5 shaded cells highlighted by cell cages in grid box 8 and 9 is cloned 3 times throughout the 9 by 9 grid. And digits appear in exactly the same position in each shaded clone region. And clone regions do not overlap. So basically, this pattern is being cloned 3 times in the puzzle. Once is these clones here, so we'll mark those as green. We have these clones here, we'll mark it as pink, and we have these clones here, which we'll mark as orange. So what happens in a clone? Clone regions, it means that the digit in the same position in each of these cloned areas have to be the same digit. So this digit must be the same as this digit, which is the same as that digit and that digit. So these 4 are the same digit. These digits, 1, 2, 3, 4, are the same digit. These digits here are the same digits, and etc., etc. So that's how clones work. And actually, I mainly picked this puzzle because of the cloning, because you will see occasionally the clone rule set. And this is actually a very unique version because I've never seen one where it's broken up. Usually it's some sort of shape that's sort of put together, usually orthogonally connected, which means that it shares an edge with other cells in the region. But this is very unique in that this is actually a very distinct, it's not connected at all. Only by essentially corners, I guess you could say. So that's an example of how clone regions work. Digits in cells joined by an X sum to 10. Digits in cells joined by a V sum to 5. So for example, if this were say a 3, that's not 3. If this were a 3, this would have to be 2 because there's a V between them and they must add up to 5, and this must be 7 because there's an X between them and then they must add up to 10. We also have digits in cells joined by a black dot are in a 2-to-1 ratio, and I chose that specifically because we already have one digit here. So if this were 3, this would have to be 6 because this has to be a 1-to-2 ratio between these digits because there's a black dot between them. We also have digits in cells joined by a white dot are consecutive, and not all X's, V's, or dots are necessarily given. So, for example, if this were, say, a 6 here, this would have to be 5 or 7 to make sure that these digits are consecutive because there's a white dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, I'm going to highlight these cells that are the same and just make them a color. So this will make blue. These will make yellow. These will make, on the end, will make orange. These will make green. And these will make pink. So these are all the same digit. We know that the blue and the orange add up to 5, and the pink has to add up to 10 with the blue digit, which is low. So the blue digit has to be 1 through 4. The orange digit has to be 1 through 4. The pink digit must be 6 through 9. And they have to be 5 distinct colors because they all appear in row 3. And therefore they are unique digits. Green is in a 1:2 ratio with blue. That's interesting. Blue can't... Where is blue then? Pink is 6 through 9. Where is pink in column 9? Can't be here because of pink in the box. Can't be here because of pink in the box. Can't be here because these must be 1 through 4 because they add up to 5. And 1, 4, and 2, 3 are the only digits that add up to 5. So they have to be here. So this is pink, which means the pink has to be 6 or 8. They have to be 6 or 8. To be in a 1:2 ratio with another digit. And therefore this blue must be 2 or 4 here, which makes the orange 1 or 3. So the blues, let's remove that, it's 2 or 4. The oranges are 1 and 3 to add up with the 2 and 4 to add up to 5. Green. Yellow, we don't have very much information. This is consecutive with 6 or 8. So this has to be 7 or 9 because it adds up to 10 with this digit. So this is 7 or 9, which is consecutive with only, which adds up to 10 with only 1 and 3. Therefore, that forces this to be 2 or 4, but this cannot be blue. And this can't be blue. Where's blue in row 6? We can't have blue here. So blue has to be this digit here. And this is the other 2 or 4 here. So we'll make that, I don't know. Dark? I don't know. So this is 1 or 3. We have 2 1 or 3s here, so this cannot be orange. Green, where is green? Green in row 1 has to be here. Two and 4 can be next to 1, 2, 4, or 8. So this green has to be 1, 2, 4, or 8. It cannot be, well, it could be this green. This could be green. Okay. One. These two are in a 1:2 ratio, and therefore these digits have to be the same because these digits are the same, and they're only 1 and 3. 1 can only be in a 1:2 ratio with 2, and 3 can only be in a 1:2 ratio with 6. So this is 2 or 6 here. Wait, how did I get that as... Yeah, 6 and 8. 6 cannot be here. Because if this is 6, that would be in a 1 to 2 ratio only with 3, but this can't be 3. So therefore, pink has to be 8. So pink is 8, which means blue has to be 2. So blue is 2. That's in a 1 to 2 ratio with 1 or 4. So this is 1 or 4. 2 adds up with 3 to add up to 5. So this is 3. No 2 or 8 here. No 2 or 8 here. 1 is consecutive with this digit, but that would force it to be 2, but we already have a 2 in the column. So green cannot be 1. Green has to be 4, which makes this 4, and this is green, which makes this 1 and 9 to be consecutive. 2 is in a 1 to 2 ratio with 6, so this is 6, this is 6 here. 6 and 8 are consecutive with 7. Or yellow cannot be 9, and it cannot be 5. And those are the only remaining digits possible in row 3. Or it could be 5. Yeah, it can't be 5 because yellow adds up to 10 with another digit. And 5 only add up to 10, but then they would have a duplicate in the same row. So therefore, yellow cannot be 9, yellow cannot be 5, yellow has to be 1, which adds up to 10 with a 9. 4 and 6 add up together to add up to 10. We have 5 and 9 as a pair remaining in row 3. Let's see. What else do we have? This is in a 1 to 2 ratio. It cannot contain 6 or 8. So it's guaranteed to have a 2 to be in a 1 to 2 ratio with 1 or 4. So this is guaranteed to have a 2. And we can have 1 being here and 4 being here. Either way, these digits cannot add up, cannot be 2 and 8 adding up to 10, because we already have a guaranteed 2 in the box. So, and this can't be 2, 8, it cannot be 3, 7, or 4, 6, so this must be 1, 9 as a pair, which eliminates 1, 9 in the rest of the box, so this can't be 1. It's 2, which is in a 1 to 2 ratio with 4. That eliminates 2, 8, and 4, 6 for this 10 pair, so this must be 3 and 7 as a pair. That means the remaining digits in this box 7, as I said, we have typical Western reading notation to number the boxes. They have to be 5, 8, and 9. And this can't be 8, so this must be 5 or 9 here. This is 5, 8, or not 5, 8, or 9. It's 5, 6, and 8. Apologies for that. So this is 5 or 8. This can't be 6 or 8 here, so that forces this to be 5, which makes that 8, which makes that 6. 5 eliminates 5 here, so it's 9 and 5. Remaining digits of box 9 are 2, 5, and 7. And this cannot be 2 or 5 because of 2, 5 in the row, so that's 7. This can't be 2 or 7, so it's 5, which makes that a 2. Remaining digits of column 9, we have 2 and 9. Remaining digits of row 7, we have 1, 3, and 9. This can't be 3, and if it's 1 here, it would force 2 to be here to be consecutive with it, so this cannot... Wait. Oh, this is not 8. I don't know how I got 8 there. Okay. Apologies for that. This can't be 6 or 8, it's 5. This can't be 5 or 8, it's 6, which makes that 8. So that was the problem there. That makes this 9, that's 5. This still is the same way. This can't be 2 or 5, it's 7. This can't be 2 or 7, it's 5, which makes that 2. That leaves us as a 2, 9 pair here. We are still left with 1, 3, 9 here. 3 can't be here because of 3 in the column. 1 can't be here because that forces this to be 2. Therefore, that makes this 9, which makes that 8, which makes that 7. This can't be 1 or 9, so it's 3, which makes this not 3 or 9. It's 1. Um, Remaining digits of column 7 are 5 and 6. This can't be 6 because of 6 in the box, so that's 5, that's 6. That leaves in box 7, box 6, the remaining digits of 5 and 7. In column 8, then, we are left with a 4. Remaining digit in row 8 is 5. Remaining digits in row 9 are 4 and 6. And this can't be 4 because of 4 in the column. So that's 6, that's 4. Okay. 9 eliminates 9 here, so that's 1 and 9. Remaining digits of column... The rest, well, we're not doing necessarily Sudoku. Remaining digits of row 4, we have 5, 7, and 9, and this can't be 9 here, so this is 5 or 7, which means where's the 9 in row 4? It must be here. Remaining digits of column 6 are 6 and 7. So we have 6 or 7 here, 6 or 7 here. Remaining digits of column 4. We have 1, 5, 6, 7. This can't be 1 because of 1 in the box. This can't be 1 because if this were 1, it could only be next to 2 or consecutive with 2, and we already have a 2 in the box. So whereas 1 in column 4, it must be here. 5, 6, or 7 can be consecutive with 4 through 8, but this can't be 4 or 8 because of 4 or 8 in the column. So this must be 5, 6, or 7 here, and this cannot be 6 or 7 because of 6 or 7 in the column. So this is 5, which is only consecutive with 6 out of 5, 6, or 7, and that forces this to be 7 there. That makes this not 7 there, so it's 6, which means this can't be 6. Remaining digit in box 2 is a 9, so 9 eliminates 9 here, so that's 2 and 9 there. Remaining digits in row 2 are 6 and 7. This can't be 6 because of 6 in the column, so it's 7 and 6 there. 7 eliminates 7 here, so it's 3 and 7 there. Remaining digits of row 1 are 1, 2, and 3, and this can't be 1 or 2 because of 1 or 2 in the column, so that's 3. This can't be 3 or 1 because of 1 in the column and 3 in the row. That's 3 we celebrate because we are close to solving this. So this must be 2, that's 1. Remaining digits in column 1 then, and this is all just normal Sudoku now. This has to be 4 and 7, and this can't be 4 because of 4 in the row, so that's 7, which makes that 4. Remaining digits in column 2 are 5 and 8. So this is 5, 8 as a pair. Remaining digits in column 3 are 3 and 9, and this cannot be 9 because of 9 in the row, so this is 3, that's 9. Remaining digits of column 5 are 3 and 8. And this cannot be 3 because of 3 in the row, so that's 8 and 3. 8 eliminates 8 here, so it's 5 and 8 here. 7 eliminates 7 here, so it's 5 and 7, which eliminates 7 here. So that's 5, and that's 7. And that's how you solve it. Yeah, that's what one good thing about clones is that it will give you a lot of information about those digits that have to be in certain positions, right? So this was very interesting aspect, and the break-in sort of happened over here, right? Because pink had to be adding up to 10 with a low digit, and it had to be a 1 to 2 ratio with a different digit, because this couldn't be the same digit. And so that forced this to be 8, and then everything flows essentially from that information. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.